I am E Krishna Rao Patro, Associate Professor in the Department of Computer Science Engineering from IARE College, Institute of Aeronautical Engineering. So today we'll discuss about selection sort, one of the important sorting technique, that is selection sort. The name indicates you have to select the minimum element and put in the first position. Then select second minimum, put in the second position. And then select third minimum, put in the third position. Like this, you have to repeat n time. That's why the name indicates it is a selection sort. You have to select it and put in a proper position. Like this, you have to repeat n time. So the name says sorting. Sorting means arranging the element in ascending or descending order. If you want to arrange the data in an order, it's called sorting. So sorting may be ascending or descending order. So there are the steps you have to follow while writing selection sort. Step 1. Starting from the first element, we search the smallest element in the array and replace it with element in the first position. So step 1 says choose the first element and try to find the smallest element in the array and replace it with the first position. In the step 2, we then move to second position. That means after first you have to go to second position. Then look for the second smallest element on the array and move to the second position. In the step 3, again find the next smallest to the next position. Like this, you repeat this process till nth element. So n time this process has to continue. That means if there are n number of elements, you have to repeat n time. This is one of the simplest sorting technique. Assume the array having 5 elements: 21, 54, 36, 18, 29. Please observe here, there are 5 elements. If you see the 5 elements, which is the smallest here? The smallest is 18. So this 18 has to come to 0th position. After 18 has come to 0th position, the next 2 elements you have to sort. So that means for the second position you have to sort. So after first iteration, 18 will come to the first position. In the second iteration, the second smallest element will come. So here, please observe here, which is the second smallest after 18? So 21. So 21 will come here. After second minimum, then you will find third minimum. So 18 and 21 over. The next will be 29. So 29 will come down. Then 20, 36. And then 54. Like this, it will repeat. So try to see now step by step in iteration. In the first iteration, the 18 will come to the 0th position. Now, I will assume m equal to initially 0 and I also start from 0 and compare this 21 with 54. Whether array of m is greater or not. If this element is greater, then you have to swap it. 21 is greater than 54. If it is yes, then store. Otherwise, no. So here condition fail. So no need to remember the position. J++. J is incremented. Then compare whether this mth position data is greater or not. 21 is greater than 54. No. So no need to. Then J is incremented. J has gone to second position. Now you compare this mth data. 21 is greater than 36. So here also condition fails. So no need to remember the position. J++. Now J has gone to next position. Then come m with the jth item. Here a of m is 21. Again jth element is 18. 21 is greater than 18. 21 is greater than 18. Yes. So condition satisfied. If it is satisfied, try to remember the position. So this position you know. So this is the till now 18 is the smallest element. Now J++. J has gone to next. Now here m is 3, third position. Now you compare 18 is greater than 29. No, condition fail. If a condition fail, no need to remember. J++. Now J has gone out of the boundary. If J has gone out of the boundary, it says this iteration is over. So swap it. Smallest element was 18. The 18 has come to 0th position. And here 21 is that 21 has come to this place. So these two are swap. Now first iteration means the first item is already sorted. Now come to the second. So in the second iteration, I have to swap 54 with second minimum Actually, second minimum is what? 21. So at the end of this iteration, 21 will come to this position. Now compare M with I. M and J, say 54 and 36. 54 is greater than 36? Yes. So M will be remembering that position. M equal to now J. The J plus plus. J has come to next. Now compare 36 with 21. 36 is greater than 21. Yes. So condition also satisfied. So try to remember the position. So whenever the condition satisfies, try to remember the position. Now M is at third position. Now compare this value with 29. 21 is greater than 29. No, condition fail. No need to remember the position. So that means this value you have to swap with first position. Because I is here 1. Ith position with mth position you have to swap. So after swapping, so this 21 has come to this position. So 54 has come to this place and 21 has come to this place. So that means 0th position and first position over. Now in the third iteration, the first 2 are over. The remaining 3 elements will do the process. Now initially M and I both are same. 36 with jth element. 36 is greater than 54. No, not need to remember the position. Then 36 with 29. 36 is greater than 29. Yes, so remember the position. So whenever the condition satisfies, you have to remember the position. Now when the J is out of boundary, that says iteration is over. Now in that case, you just interchange the value. So 29 has come to this place. So at the end of each iteration, the smallest element will come to that position. Now in the next iteration, these 54 and 36. So that means at the end of this iteration, this element will be swapped. Now compare with this. 54 is greater than 36. Yes, condition satisfies. Try to remember the position and interchange. After interchanging, my 36 has come to this position. So now there is a single element. Now here no more swapping required. So finally the sorted element will be like this. Okay, 18, 21, 29, 36 and 54. So you can write a small selection sort program using Python. Assume there is an array with the values 64, 25, 12, 22 and 11. Now to sort this one, you have to write loop within a loop. The outer loop will repeat n number of times. If there are 10 elements, it will repeat 10 times. If there are 5 elements, it will repeat 5 times. So my outer loop start from 0 until length of the array. Initially, I will remember the position from which position I will start, because in that position the data has to come. So minimum index is I. So ith position will be my starting index. Then I will start with the remaining elements j in range of I plus 1 to length of a. That means if I is 0, then I will start from 1. If I is 1, then I will start with 2. If I is 2, start with 3. If I is 4, start with 5. If I is n, start with n plus 1. Like this. So j start from I plus 1. J in range of I plus 1 to a, because ith element is fixed now. Remaining element I have to compare with ith element. So here I am taking the condition A. If a of minimum index is greater than a of j, then I will store that position. So minimum index is j. So I am not remembering the value, I am remembering the position. So minimum index equal j. So like this, it will repeat until the end of the array. So at the end of the iteration, I will be knowing the minimum element's position that is stored in the min index. Once the loop is over, then interchange these two. This is a swapping technique. A of ith element and min index interchange with min index of a of j. So this process will continue for n number of times and finally print it. Okay. And this is the time complexity. The best time complexity is order of n square. You can write like this also. And the average case also order of n square. And our worst case also order of n square. And the memory requirement for the entire process fixed, so order of 1. And it's a stable sort and it is also in place sorting, because it is not changing whenever the values are same. It is in the same position. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.